we are going to be looking at simplifying radicals. All right, so yeah, what is a radical? What is mixed and entire radicals? We'll see. Just a bunch of definitions. These are already on the note, so just read through them. I'll just highlight some important things as I go through this. So first of all, a radical is just any kind of root. Usually we look at the square root, but the radical is just that fancy little symbol that we have for that root. In particular, we do have some special radicals, which we call surds. It's a weird new definition, but it's fun. It's basically an irrational radical. So what I mean is it's a radical you can't get a nice answer for. So for example, square root of 4, hopefully we all know that that's 2 or negative 2. But it has a nice answer. Whereas the square root of 6, if you try to type that in, you're just going to get some decimal that just keeps going on and on and on. It's an irrational number. There's no pattern to that decimal. And for this reason, we don't want to round off that decimal value, because if we round it off, then we don't have the exact value. And so we often like to just leave our answers, if it's a surd, just as that square root, or whatever kind of root it is. We also have just a couple other definitions. An entire radical, so that's just in a sense, like a square root with just a number in it. There's nothing in front. Whereas a mixed radical has some coefficient, we could think of it as, in front of that square root. And you can also kind of compare it to variables. 2x, that's got a coefficient of 2, whereas an entire radical has no coefficient, like just a regular x. So our goal, whenever we're dealing with square roots now, is we always want to answer the problem so that they're left as mixed radicals. And we'll see how to do that in the below examples later in the lesson. Okay, so there's this mini investigation. So pause the video, and then I will magically have the answers appear in a few seconds. There are the answers. So what's key is that whenever you did multiplication, you should have gotten the same answer. Whenever you did division, should have gotten the same answer. When we had addition or subtraction, we get different answers. So definitely double check so that you're typing it into your calculator. You might need to use brackets. So when you type in the square root, put in brackets and then put in your numbers within the brackets. That might be what's needed to make sure that you're getting the correct value. So just double check that if you were having some trouble just with the calculators stuff. Okay, so we can summarize this in some rules. So the rule is if you have two radicals multiplied together, that's the same as just multiplying the two numbers as if they were under a single radical or under a single square root. If we have two, or if we have a fraction, we could break that fraction apart. We can go in either direction actually, but we can break that fraction apart into the fraction of two separate radicals. The last one is just if you square root a number and then square it, it just gets you back the original number. And that's because the operation of square and square root is their inverses. And if you apply an inverse to a function, it brings you back to the original input. So that's why we get, or that's one way of thinking about it, to get the original a. All right, so let's put these rules to work. How are we going to get things to mixed radicals? Again, that's kind of the goal with a lot of what we're going to be doing. So to start off with, what I'm going to do, it's going to seem a little random, and then we'll go through the reasoning behind it. We want to make use of that multiplication rule. The multiplication rule just says that if I have something multiplied, let's say we have 9 times 5. Again, 9 times 5 is the same as 45, so I could rewrite 45 as 9 times 5, and that's perfectly fine. Now that I've got that written as multiplication, I can just split it up into, well, 2 separate multiplications, because that's the radical rule we just saw. And, well, here's where the fact that I chose 9 is going to come into play, because 9 is a nice number. In fact, it's a perfect square. So we can actually take the square root of 9 and write it as, well, the square root of 9 is just 3. So 3 times the root of 5. And when we're multiplying something, like a number by a radical, we just drop the multiplication symbol. You write them next to each other like this, 3 root 5. That indicates multiplication between the two. So this is the mixed form of that above entire radical. Okay, and that brings up kind of the key point. So I chose 9 because it had a nice square root, and I'm just going to write this over here. So essentially what we do is we check if there's a perfect square. That divides into the number. So why a perfect square? Well, those are the numbers that you can nicely square root. So remember, a perfect square is just like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Continuing along, you get 25, 36, 49. And you could keep going, but these ones will probably do for the most part. So now we take a look at negative 5 root 27. Let's ignore the negative 5 for now. Let's focus on that radical. So 27, how can we break that up? Well, check perfect squares, and what we'll see is that, well, 9 is a perfect square that you can divide into 27 and turn it into 9 times 3. And again, break that apart into root 9 times root 3 using that radical rule. And now that root 9, we can take the square root of. So I'm just going to write it in brackets for now, like this. So negative 5 times 3 times root 3. Now we have two numbers in front of that square root. Both those numbers are actually being multiplied, so you can just combine them together. So what's negative 5 times 3? Well, that's just negative 15 root 3. And there we have it. We've now converted that mixed radical, and we've actually simplified it even more. So we always want to get it down to the simplest form where whatever's inside the square root can't be broken down any further. All right, let's continue. So let's express each of these now as an entire radical. So we've mixed radicals, we're going backwards. Oftentimes we don't really need to do this, but this is just some practice with radicals, making use of those radical rules. So since we're doing the opposite before, let's just think in the opposite direction. So to finish things off, we always had that coefficient which came from a square root. So what we want to do is figure out, when we're down here, what square root gives us this coefficient? Well, just square the number 3, which is 9, and well, the square root of 9 must be 3. And that's actually making use of, we're kind of in disguise using this rule. Kind of the last one that was written there, the square, or a number squared, and then square rooted is just the original number. Well, the square root of 9 is just 3, because that's 3 squared. And then we can now multiply 9 and 7, since we're multiplying two radicals, so we can just bring them together. And that would be 63. So that's going to be the idea. So convert that number in front into a square root. So try these out actually before I even go through them. So feel free to pause the video, and I'll just continue taking these up. So we've 8 root 10. So what square root gives us 8? Well, 64. The square root of 64 gives us 8. And again, you could have gotten that by doing 8 squared. We now just need to multiply those two numbers, because we're multiplying the two separate radicals, which will lead to, well, 640. And there we have it. That is the entire radical. What about a fraction? Well, what were we doing? We were always squaring the previous numbers to get what was inside the square root. So let's just do that. I'm going to do that in 2 steps here. And 2 squared, if you're squaring a square root, you can just, or squaring a fraction, just square the individual parts. So 2 squared is 4, 3 squared is 9. So 4 over 9, actually, if you take the square root of that, gives you 2 over 3. And now that we've got it, as two radicals multiplied together, just multiply the fraction by that 45. I know, we gotta do some fraction multiplication. It's okay, we can handle this. So we do 4 over 9 times 45. Well, 9 actually divides nicely into 45, becomes 5, so it's just 4 times 5, which is 20, so the square root of 20. All right, there we have it. We've got it as an entire radical. Let's continue onwards. So we've been looking at just specifically square roots, and it's a very handy tool. We've been doing it with quadratic functions, finding their inverses, and we've seen like, oh, if you just simply rearrange, say the square root of 16, or what number multiplied by itself gives you 16, that gives you x. And you could have a positive or a negative answer. But what if instead we didn't have a square? What if we had something like the exponent 3? Well, again, we still want to take the root. We just want to now take the third root of 8. So what number multiplied by itself 3 times gives you 8? Or let's say we have the exponent n, whatever that number is, just take the nth root. So what number multiplied by itself n times gives you 243? That's the goal with these. So what kind of notation can we use for these other roots? Like, how do we know if we're taking the third root? How do we know if we're taking the nth root? So let's just go through that. So we write down a radical, just like we always would. But now, in kind of the top left corner, we just write down whatever the value of the root we want to take. So if you want to take the third root, like below, where we're saying x is the third root of 8, or the cube root of 8, just replace that with a 3. Or if you want to take the fifth root, because it's x to the 5, of 243, just replace that with a 5. And there we have it. That is the notation. And I mean, technically speaking, you could put a 2 there for a square root, but if we're doing a square root, we just assume like a regular radical symbol is that square root. So we don't need to include it for those ones. So what I want to make sure is make sure that you can do this on your calculator. So on your calculator, you kind of see this little picture up here. You will maybe potentially see a button, like you might have a square root or a square button. It might be that hat symbol. It might be x to the y on your calculator. Whatever it might be, it usually accompanies a square root of x button or something along those lines. And so take a moment, find that button, and then just make sure you know how to use it. Sometimes what you might have to do is, let's say if you're finding the third root, you might have to type in 3 first to tell, oh, the third root, and then that fancy radical button. Usually it's like a shift or a second button that you'll have to click to be able to get there. And then, well, we're doing the third root of 8, so you'd kind of click it in that sequence. But again, each calculator is a little different, so make sure you know how to do it with your calculator. Okay, let's continue onwards. So just some simple operations with radicals. So the goal here is we have some multiplication, we want to multiply it together, and we want to then just simplify it as much as possible. So for example, we have 5 times 8 here, so we know we can bring it together under a square root, which will become 40. Now, what we can do is we want to take that 40 and break it apart, like we did before, where we're checking what perfect square divides into 40. In this case, it's 4. So 4 times 10 is the same as 40. And split that apart so that you can rewrite this as root 4 times root 10, which then becomes, well, 2 root 10 when you take the square root of 4. So that's the idea here. So combine, simplify. Try these out first yourself, just by pausing the video, and I'll keep going through this. So root 15 times root 6. So again, combine them together. So you get root 90. Then what multiplies together to give you 90? How can we do that with a perfect square? Well, in this case, it's going to be 9 times 10. And so break it apart into root 9, root 10, which then when you take the square root of 9 becomes 3. So it becomes 3 root 10. And so there you have it. You've simplified that particular statement. Okay, and the last one, we've got a fraction. So if we want to simplify the fraction, there's a number of ways you could do it. You could try to reduce the fraction if possible. What I'm going to do is I'm going to use that fraction rule that we saw before. So if you have a square root of a fraction, you can look at it as, well, the square root of the numerator and the square root of the denominator. And then just simplify each of those individual parts. And what we'll see is that things will magically work out. So how can we simplify root 147? This one's a little bit more work to figure out, but what you'll see is it's actually this 49 times 3. What about 108? Well, that's actually 36 times 3. So sometimes it does take a little bit of effort sometimes, but again, you're just checking the perfect squares. You don't need to check every single number. So we can break this apart into 49 times root 3, 36 times root 3. You might be noticing they both have root 3, so we will deal with that later. But square root of 49, that's just 7, so 7 root 3. And square root of 36 is just 6, so 6 root 3. Okay, so we've got both the top and the bottom simplified, and if you take a look at it, root 3 cancels out. So you're actually just left with 7 over 6. And there you go. That is that one simplified. You actually managed to get rid of all the square roots. And that is how we deal with these radicals and simplifying them into mixed